Here's a short video on spreadsheets, which is a pretty useful tool when you're working with compound interest. So I want to spend a few minutes talking about what spreadsheets are and how you can use a spreadsheet to do the compound interest problems. A spreadsheet is a collection of cells arranged in rows and columns. The rows, horizontal lines, are usually numbered 1, 2, 3, and so on. And the columns, the vertical lines, are lettered A, B, C, and so on. There are three kinds of things that you can enter in a cell on a spreadsheet. You can enter text, you can enter numbers, and you can enter formulas. So let's take a look at a sample spreadsheet. Here is a fairly simple spreadsheet that I've created to help me when I'm doing the compound interest problems. So on this spreadsheet, you see the row numbers 1, 2, 3, 4, and so on, and the column letters A, B, C, and so on. And each cell in the spreadsheet is identified by the column and row in which it appears. So for example, this number 0.24 is in cell B2 because it's in column B, row 2, and so on. And we see in this spreadsheet, for example, that cell A1 contains some text. The text beginning amount, left parenthesis, P, right parenthesis. Another example, the cell A2, right here, contains the number 500. And finally, the cell C4 really contains a formula. So when you click on a cell, and I had clicked on cell C4 when this screenshot was taken, when you click on a cell, you can see in this row up here above the column headings what is actually in the cell. So what's actually in cell C4 is the formula equals A2 star left parenthesis 1 plus B2 and so on. I've displayed the formula down here also. So what the spreadsheet does is it does the calculations described by this formula, but replacing A2 by the contents of cell A2, and B2 by the contents of cell B2, and so on. And the result of the calculation is what actually appears in the cell itself. One thing to notice here, that when you enter a formula in a spreadsheet, it has to begin with an equal sign. That's how the spreadsheet knows that it's a formula. Okay, here's the same spreadsheet. One thing I wanted you to notice was that this formula, which is what's really in cell C4, is the formula for the ending amount in a savings account paying compound interest. If capital P is what's in cell A2, if the annual interest is what's in cell B2, if the number of compounding periods per year is in cell C2, and if the number of years is in cell D2. And that's what I have entered here in the four cells A2 through D2. So this 3,346.46659 will be the ending amount in an account which began at $500, pays 24% annual interest compounded 12 times a year or monthly, for 8 years. And so this spreadsheet makes my compound interest calculations a lot easier. If I change these numbers in cells A1, A2, B2, C2, and D2, then the number in cell C4 will be recalculated. So rather than having to enter the numbers in the formula for compound interest every time I want to do a calculation, I simply enter the beginning amount, the interest, the number of compounding periods per year, and the number of years in cells A1 through cells A2 through D2. So for example, if we took an account with a beginning balance of $700 and an annual interest of 7%, compounded quarterly for 5 years, I would revise the spreadsheet so that it looked like this. 700 in cell A2, that's where the beginning amount goes, that's where P goes. 0.07 in cell B2, that's the annual interest expressed as a decimal. Compounding quarterly means 4 times a year, so in cell C2 would be the value of N, number of compounding periods per year, which in this case is 4, and a 5 in cell D2. We're going for 5 years. And the spreadsheet has done the calculation, $990.34, rounding to the nearest cent. So there are several spreadsheet programs that are available. There is Excel, which is a Microsoft product. This is a spreadsheet program you may already have on your computer. If not, it can be purchased from Microsoft. There is a program called OpenOffice.org Calc. This is a free spreadsheet program, cross-platform. You can use it on a Windows operating system, Macintosh, or on the Linux operating system, a Linux operating system. There's also LibreOffice Calc, which is similar to OpenOffice Calc. It's a free spreadsheet program, also cross-platform, and there are several others. And a fourth possibility is Google Sheets. This is a spreadsheet program that you can use online, and this is what I am using for the examples on these slides. If you don't have a spreadsheet program on your computer, downloading either OpenOffice or LibreOffice is fairly easy, but a good way to start might be to use Google Sheets. And what I want to describe briefly is how you can get started. So if you decide you want to try Google Sheets, you can go to sheets.google.com and sign in with your EMU email. If you're not already signed in, you may not have to sign in. And then there's a large plus sign under the word Start a New Spreadsheet. And if you click on that, this will open a spreadsheet which will look something like this. This is similar to the spreadsheet we saw before on these slides. It's just that nothing has been entered at this point. Clicking on the File menu item right here will give you the opportunity to rename the sheet and to download the sheet if you want to. And once you've gotten this far, you can copy the spreadsheet from the beginning of this presentation and you will have a handy tool for doing the compound interest homework. If you already have a spreadsheet program installed on your computer like Excel or OpenOffice or LibreOffice, you could do the same thing on your computer. Open the program and you should see a blank spreadsheet appear.